Hey there, what up, space weather types? We got a major geomagnetic storm on the way, and we've got an increasing likelihood of large solar flares, which is about to go into effect in the next 24 to 36 hours. We've also got some indecision happening on the east side of the sun. It's a magnetic tug-of-war. We'll tell you all about it and lots more tonight on the Daily Space Weather Show. These are 24-hour videos from the Solar Dynamics Observatory, and we're showing 171 angstroms, the house favorite wavelength. It's part of the extreme ultraviolet light spectrum, also 211 angstroms. And let's take a close-up tour of the northern polar region. So first of all, we're going to take a look at this prominence, a filament hanging off of the edge of the limb over there by the Earth scale. It's a good opportunity to show you the size of solar features. There's an extreme close-up of that, quote, small, end quote, filament. By small, I mean many times the diameter of the Earth. Here's the polar region, and that coronal hole that you see up there is of South Pole orientation. Yes. So the solar cycle is approaching solar maximum, although we don't anticipate it being there yet. Some of that south polar magnetism is already up at the north heliographic polar region. We've also got some extreme close-ups of these setting active regions in the northwest. Another large filament over there. Here's a step closer. Huge loops of plasma there being suspended by magnetic fields and defying the massive gravity of the closest star. Here's the equatorial view. And let's talk channel. Yeah, channel. First of all, press the like button, whoever you are, whether you're new or if you've been watching the channel for ages. Press the like button, or else. Also, press share, press subscribe. If you're new to the channel, do yourself a favor and get the world's most comprehensive daily space weather content onto your YouTube subscription feed. Also, visit our homepage. It's got a number of paid endorsements that we will cover now. So please help to support the channel, increase the probability these videos will continue to exist, remain publicly visible, and free for all to view, as we strive to make it a sustainable operation. Smashomash.com is the homepage, and welcome to the Neo-Renaissance. One of the links you can find there is the link to the Hemp Lucid shop. Perhaps pick up yourself some organic full-spectrum CBD hemp seed oil suspended CBDs. It's good times. And you can save a bunch of money by shopping via our link. Save 10% site-wide by entering the promo code SMASHOMASH10. Yeah, SMASHOMASH10 will save you 10% at hemplucid.com. You can also help out the channel by shopping via our link found below this video. And you can also find a link on the homepage at the homepage of SmashoMash.com. The homepage at the homepage. You can also find our Amazon shop. Today's featured product is the Liquid Sun by Alexander Unziker. Have you considered the possibility that stars may be made of condensed matter instead of gaseous plasma? I know it's considered blasphemy, but guess what? It's got all kinds of crazy implications to cosmology. It indicates that stars are probably a lot more stable than most people realize, and, well, it tells us a lot about some changes that are likely coming soon to a cosmology textbook near you. Alexander Unziker's The Liquid Sun. You can find it on our Amazon shop at amazon.com/shop/smashomash. Another paid endorsement is our Redbubble shop. And if you've never seen that, here's a peek at our bestseller. So do not pole vault the caldera, folks. I know it might seem like times are real bad right now. However, while things could get worse, our finest days lie ahead. If you're going through hell, keep going. And if you're going on a volcanic vacation, do not pole vault the caldera. This public service message brought to you at massive personal risk and expense by Smash staff and I. Give Smash staff a raise by picking up some merch. That's our featured product of the day. Do not pole vault the caldera. It could be unhealthful Links below the video to the Redbubble shop, as well as on the homepage at smashomash.com. Another paid endorsement is our own subscription services site at smashomash.com/smashteam. We send out email alerts about videos just like this one. Those are free. If you're unable or unwilling to open your cobweb-encrusted wallet, you could always join at the bronze level. That costs you $0 per month. Silver is $2.99 a month with additional content. Gold is $9.99 a month with content on top of that. And there's even a gold annual paid-up subscription, which is the best value. It's like getting 4 months for free, as it includes complimentary merch. Smashomash.com/smashteam. Get additional content and help keep these videos existent, publicly visible, and free for all to view by supporting the channel. Next, November 9th and 10th. That's November 9th the whole day and November 10th to date. We do see some evolution happening there of that sunspot in the northwest. Some umbral consolidation happening up there. Besides that, mostly stable here. And just about all of the sunspots are currently in the western hemisphere. Now, as they approach the western limb of the closest star, they do become more likely to produce large solar flares. There's the colorized magnetogram for the same time period, November 10th and November 9th and November 10th to date. Quick reminder, there is a CME on the way. And before we talk about that, I don't know what that garbagey ad was, but I got rid of it quickly. Let's take a look at volcanoes and earthquakes. There's been an earthquake uptick. And for some reason, volcanoes today is only showing 2 volcanoes, so there they are. Luatolo producing a 6,000-foot ash plume, and Sangay in Ecuador producing a 20,000-foot ash plume as it explodes, flight level 200. Let's move on to earthquakes. So here's seismic activity for the past 90 days. We are seeing quite a lot of activity. Not just under Iceland, but also around the western Pacific. The Pacific in general, in fact. So these are the quakes of a 5 or greater magnitude. Papua New Guinea had a 5.0 at 1:06 this morning on November 10th. Then a 5.9 at Indonesia. That was the largest quake of the past 24, I think. No, I stand corrected. There was a larger one. So that 5.9 was at 3:50 this morning. Then a 5.2 near Samoa. That was at 6:45 this morning. And then south of Kamchatka in the Kuril Islands, we had a 5.8 at 10:10 this morning. Then Chile had a 5.1, so opposite side of the Pacific Ocean there. On the coast of Chile, that 5.1 at 15:27 Universal Time. Then Iran had a 5.2. That was at 15:36 Universal Time this afternoon. Then in the Caribbean, the Dominican Republic had a 5.0. That was at 17:22. Then Iceland, we're going to take a look at this one. A 5.1 at Iceland, folks. Out there on the Reykjanes Peninsula. So there's a location of that. And they are kind of preparing for a major eruption to happen in Iceland. So don't be surprised to see major fissures start to open. Possibly new cinder cones about to form. Also a 5.0 at Iceland there. The 5.1 was at 1800. The 5.0 was only 9 minutes later at 1809. Then Band C had a 6.1. So that's a lot of action for earthquakes for the past 24. That 6.1 was at 2045 Universal Time. Then Japan had a 5.3 at 2050. Then Band C had a 5.0 at 1021. Then more at the Band C and more at the Band C. Those are aftershocks, and it's time to return to space. Dag. Quite a bit of stuff going on there as far as seismic activity. Next, the past 24 hours in ionized helium, 304 angstroms SDO. There you have it. And guess what? Toward the end of that video, another CME popping off. Is it earthly directed? It came from somewhere south of the Earth scale there. We'll analyze it for you to let you know if there is yet another solar storm on the way. Next, some more solar stats. The 10.7 centimeter radio flux now at 145 solar flux units. So there's the 1 year graph of the radio flux. What happened? There you go. 145 is the current radio flux. And there's the Space Weather Enthusiast dashboard. And check it out, folks. NOAA is forecasting a geomagnetic storm of a G2, a 6.33 is what NOAA is calling for. That is a pretty significant forecast there by NOAA. So expect a significant geomagnetic storm once again showing up here on planet Earth. So that's what's going on. Late tomorrow night into early in the day on Sunday. So Saturday night into Sunday, we might see some more fireworks. Fingers crossed. Exciting stuff going on. So let's break out the Enlil spiral there. What am I doing? There we go. So there's the Enlil spiral. That's NOAA's forecast. We'll let that play through so you can see the full model run. So NOAA has this, I believe this is a little bit faster speed than NASA's forecast. Most CMEs do take about 3 days, folks. And here's NASA's forecast. Our other Enlil spiral. This depicts dynamic pressure. So pretty similar forecast there. For NASA and NOAA. So that's, again, likely CME impact coming Saturday night into Sunday morning. Could be another fantastic opportunity to see aurora at mid-latitudes. Maybe even low latitudes, depending on what part of the world you're in. Exciting stuff. Next, Earth's magnetic moment from space. There are the past 4 hours of magnetohydrodynamic pressure out to about 12 Earth diameters. It's our geospace magnetosphere movie, and we do have geomagnetically calm conditions. Not to last too much longer here. Next, Earth's magnetic moment from the ground. This is changes to Earth's B field, geospace delta B. The B field being the field that goes through the magnet, this magnet being Earth. Magnetic flux density is in the units of nanotesla. Again, it is geomagnetically chill on planet Earth. KP1 is the current planetary K index. KP1 is what's up. And next, looking at the real-time solar wind. There you have it. That's the ACE, and we have missing data here, so let's switch to the Discover, which is showing 2 separate signals here. So it looks like the higher speed one is winning out. You can see 2 different plasma temperatures down here in this green line. The yellow line showing 2 different speeds, 521 versus about 600 kilometers a second. So 2 different speed streams there, going past Discover at the same time. And also some different densities there. Half a proton per cubic centimeter all the way up to about 3 protons per cubic centimeter. Current conditions are showing about 3.5 protons per cubic centimeter for the solar wind density, solar wind velocity here, still elevated at 511 kilometers per second. GOES magnetometers here are pretty chill. So that's the past 3 days. Expect to see some big variations in the GOES magnetometers here as that major solar storm hits. I said when it first launched that we could see as high as a KP 7.33 from it. So not too far out of line with NOAA's forecast there. And next, viewing the top view ecliptic plane field plot. So this is one of the best sets of data, and guess what? There's a tug-of-war going on in the eastern solar limb once again. It's a miniature Terminator event. So you're going to see at the end of this video the North Pole current sheet just cancel out the South Pole current sheet. That is indecision going on. So the barrier between north and south is very close to the equator. That's what's going on there. And when we show the other views, you'll be able to see the fields waving all around on the east side. But there is another Eastern Limb miniature terminator event going on right now. So there is indecision happening as coronal holes migrate across the solar equator and things like that. So we may just see some sunspots start to form in the southern hemisphere. So don't be surprised to see sunspots forming in the southeastern limb of the closest star. That's a forecast based on what's going on there. And if we bring up the latest image, watch, I'll slowly bring this back. There you can see the North Pole current sheet taking over the entire eastern limb all the way around to the far side there, canceling out that South Pole current sheet. So a little bit is coming back, though, so some indecision happening around the eastern portion of the closest star there. So again, if that tells us anything about sunspot formation, expect to see sunspots in the southeast. Continuing on, here's our line of sight field plot, and you'll see the B field moving around over here in the east. That is what you would expect. Keep in mind, folks, we are getting closer and closer to solar maximum, probably within 1 year now. So here's our line of sight ecliptic plane field plot. You'll see that indecision happening over there in the east. Fields changing from north and south and back. And that brings us to coronal hole. So like I said earlier in the video, we've got this South Pole-oriented coronal hole up here at the North Heliographic Polar region. You can expect to see more and more South Pole magnetism collecting up there. However, expect to see the coronal hole uptick increase. So we're going to continue to see coronal holes here for the next year or two. So expect to see lots more high-speed coronal hole wind streams from transequatorial coronal holes, period. So that's what's going on. Here is SDO 211 angstroms. So Earth is right now in a little North Pole current sheet associated with these coronal holes. All the rest of these are South Pole. Even these down here are South Pole, actually. So there's this little current sheet right in here that is of North Pole orientation. So that's the scenario. And before we get to sunspots, let's talk about things like sunspot number. So there's a sunspot number. And yeah, it's at about 101 sunspots, something like that. That's the Royal Observatory of Belgium's sunspot number data. And here is our flare probability and scoreboard. Again, mostly sunspots here in the western limb, besides 3482, which is just about to cross into the western limb. So only sunspots in the west. And once again, folks, I would reiterate, as those get closer and closer to the western solar horizon there, the more likely they are to produce large flares. It's just space facts. Space facts, folks. Next, let's look at sunspots. There's a 24-hour video for you featuring SDO 171 angstroms and the continuum. I would note a little bit of umbral consolidation and migration in that sunspot group north of the Earth scale there. Let's drop 171 angstroms to add additional detail to that. Another thing about solar maximum, folks, is you can expect to see sunspots in the full latitude range. So at solar maximum, don't be surprised to see sunspots at real high latitudes and at real low latitudes. That is what you expect at solar maximum. As solar minimum approaches, once solar maximum has passed, we'll see more and more sunspots closer and closer to the equator until we start seeing solar cycle 26 sunspots. So that's just the way a solar cycle progresses. Here's the magnetogram. That'll show you some detail of what's going on with that sunspot. Again, the likelihood of solar flares goes up as the Earth-facing quiet goes away as those sunspots approach. the western solar limb. Next, solar energetic particles. The solar energetic particle event has indeed subsided. So there's a forecast for you. Proton flux here now back toward baseline levels, almost down to baseline levels, not quite. X-ray flux here, only minor flaring. So most recently we did have a long duration C-class event, but no major events. And next, going to SDO. So here's SDO 94 angstroms for the past 24 hours. And where did that C-class event come from? So it looks like it was from these sunspot groups down in the southwest. And there was a CME in there, by the way. A coronal mass ejection did occur. We'll show footage. First, another 24-hour video from the Solar Dynamics Observatory in 131 angstroms. Next, it's star chart time. That's what's going on. That's over my head, by the way. Lehigh Valley, Pennsylvania is where we're located. Skyandtelescope.org is where our star chart comes from. Jupiter and Saturn are up there. Also, Altair, Vega, and Deneb, which I can't focus on because it's almost at my zenith. But it's up there. Don't you worry. Otherwise known as Alpha Cygni. And here comes a solar system forecast brought to you by theplanetstoday.com and the Smash News Network least busted name. In news. There's where things are today as we approach new moon. Here's where things will be in a week. We'll have a crescent waxing. Next, our astronomy photo of the day, which features Pandora's galaxy group, Pandora's cluster, which features a series of massive galaxies located about 13 billion light years away. This is the most distant galaxy ever observed in X-ray. So that is, you're looking at two sets of images there. The purple is the Chandra X-ray telescope. The infrared imagery, which is most of the detail, is the James Webb Space Telescope. And check out the unprecedented detail of that galactic cluster. I would ask you, if that was within a billion years of the formation of the universe, how come all those galaxies are so modern looking? Why don't they look differently? Shouldn't primordial galaxies that old have some kind of a difference to them? Instead, it's not what we see at all. We see elliptical galaxies, we see irregular galaxies, we see spiral galaxies, edge-on disks, disks with a bulge, barred spiral galaxies, all of the normal features that you see in local interstellar space. So I find that to be interesting, don't you? Shouldn't there be something different going on if the galaxies are 13 billion, if the galaxies are that close to the, quote, formation of the universe or Big Bang, end quote? I mean, shouldn't that be? Yeah, that's, so anyway. That's the astronomy photo of the day. My point is, it is UHZ1, I guess. No, it definitely is. It's Galaxy Cluster Able 2744, known to some as Pandora's Cluster. Oh, wait, it's only 3.5 billion light years away. What am I saying? It's only 3.5 billion light years away. It's practically in your backyard, folks. Using the galactic cluster's gravitational lens to warp space-time and even magnify more distant objects. So, I see. The background galaxy is being magnified. That's what's going on. Able 2744 is that background galaxy that's at a distance of 13.2 billion light years. So I'll just leave it at that. That's the astronomy photo of the day at apod.nasa.gov, and let's get back to space, more local space that's more relevant to your everyday lives, right? So here are coronal mass ejections from yesterday. And you can see that halo eruption. That's the one that's expected to arrive late on the 11th. That's late tomorrow night, Saturday night into Sunday morning. Expecting a major CME impact from that, nearly perfectly Earth-directed CME. So that's 92 frames from yesterday. Here are an additional 79 frames from today. And there are some additional CMEs here, one right at the end, right in there, which guess what? Has more earthly directed components. I'll give it away. First we'll show before we show our custom coronagraphs, let's show C2 and C3. So there's that latest. Well, it shows up on C2 at least. Anyway, here's a little closer view. Keep in mind those are not perfectly synced. Actually, C3 is a little bit ahead of C2 there. So this latest coronal mass ejection, it's a little bit too early to tell, but it doesn't look like it's a major one. We can expect that to arrive sometime early in the day on the 14th. Possibly even midday the 13th. So, but I would say probably by early morning 14th, that CME should arrive. We'll also show stereo A. It's just right at the end there. It's not really propagating too much yet. It's too early to say, folks, but here's stereo A anyway. Stereo A located right about there where my red dot is. So stereo A's raw coronagraph on the left, difference imagery on the right. There's that halo CME that we're expecting to cause another significant geomagnetic storm. And then just at the end, a little bit more ejecta. Well, maybe it is off to the west, but I suspect it's going to have an earthly directed component. Let's check our custom coronagraphs. These are 24-hour videos. We've synced the Soho Lasco C3 in blue with the C2 in red and the SDO 193 angstroms wavelength to show the filaments as they erupt. So here's a little closer view. And that CME right at the end, it did come from this area here. So it is kind of, it's sort of earthly direct. I'm going to say that has an earthly directed component based on the preliminary data that we have here. You can see the eruption happening right from this area. So it is distinctly possible that it will have earthly directed bits. So that's what we'll say. We'll say it's going to arrive late in the day on the 13th, most likely. So it doesn't look like it's particularly fast moving. So again, the rule of thumb is that it takes about 3 days for a CME to show up. And here is our raw data. There's just 193 plus 304 angstroms by itself. In other words, we got rid of the coronagraphs. And that CME is kind of right at the end. It just comes out of this area right here. And let's move to filaments. So filaments are important too because they turn into coronal mass ejections. And so let's show some of those. Here is the what is it? It's the Big Bear ground-based hydrogen alpha telescope. I mean, we've got some great filaments here that could get names. I don't know. Name them if you like. There are 3 right here. There's a big one down here. There's a big one up here. There's one up here. There's another one over here in the east. Here's one kind of in the center of the solar disk. So a bunch of filaments are worthy of names, and if you want to name them after living people, do it over on Twitter, x.com/smashamash. Just follow the hashtag #NameThatFilament. Don't want to name filaments? I don't care. I definitely don't care. However, you can find other stuff on Twitter as well, like auroral imagery shares. Lots of things that you won't see anyplace else. So if you do social media, and if you don't, I don't blame you, but if you do social media, come join us over on Twitter. It's where most of the action happens. Not as much on Feces Book as on X. Although I would remind you that the censorship remains entirely pathetic on all major social media platforms. No free speech has not been fixed. Don't be a cultist fanboy. It's quite pathetic. Before we get to bonus features, here are the past about 3 hours from the GOES 16 SUVI. That's what's going on, and let's cut to bonus features. It's time to do just that. So, satellites community dashboard here, not showing any satellite charging hazards. It's smooth sailing for satellites at the moment. So, that's where it is. Cheers. The GOES electron flux here, still in warning levels, so pretty high levels of electron flux there. That is the electron flux measured at the F layer of the ionosphere, by the way, from the geosynchronous orbits of the GOES 16 and GOES 18 using radiography. There's the 1-year graph of the electron flux to contextualize. So pretty high levels of electron flux here. We are in warning levels after all. And the forecast model is for it to remain flat. So I would say for about 2 days it will remain flat, but then it's going to dip way back down here as it becomes erroneous because of a coronal mass ejection impact and a major solar storm. So I agree with the first green box, but the second green box, not so much. It's going to dip to very low levels once again. Next, the layer where it's measured, which is again the F layer of the ionosphere. And I guess let's cut to the full screen mode to show that. Here is the Australian Government Bureau of Meteorology's ionogram. You could call it an ionosonde if you prefer. It is the vibrational frequency of the bridge between Earth and space. So that's what's shaken at 300 kilometers of altitude, if you were wondering. And if that's Greek to you, don't worry. We'll show the anomalygram. There it is, anomaly in megahertz from a 30-day median. And again, expect on, on Sunday night's daily space weather video, expect to see a lot of red, as another geomagnetic storm should have struck by then. More exciting times for space weather, and it's only getting better, folks. Like I said earlier in the video, our finest days lie ahead. Here's the latest image, 2300 Universal Time Ionogram, 2315 Universal Time Anomalygram. We'll also show the whole atmosphere model, the electron content on the left, the maximum usable frequency on the right, for GPS and radio operators. That's what's going on. A snapshot of the ionosphere. We'll also show the total electron content. Feel free to pause the video on this frame if you're not familiar with distances in miles. Here is the total electron content on a global scale. It still looks erroneously to me. Let me know in the comments what you think. That does not look legit. Not even slightly. So let's show the anomaly from the 10-day average over North America for total electron content, free electrons, from ground level to about 12,500 miles of altitude. So things aren't too out of the ordinary there as far as that goes. And we'll close out space weather by telling you to press the like button. Press like, or we will have problems. We will find you on the internet, and we will shame you. Don't worry, we won't cast your soul into an ever-deepening and darkening abyss of doom, destruction, and already chewed dentine from 1967. That's not what you want. So press the like button. Or if you've already done that, press comment and share. Tell your friends and foes about the channel. Thanks to everybody who has. We'll close out space weather with the latest intensitygram and magnetogram. So that's what's going on. There you go. There's the full disk rock back. And it's time to get to meteorology, because I've been doing some wave chasing, and here's what I've found. That is where the world's largest waves are, in the northern Pacific. Although we have pretty calm seas here on a global scale, those waves are only about 26 footers. So not really that big of a deal. There are some big ones in the North Atlantic too, similarly sized there. We've got low pressures on each side of the U.S., the North American continent. So that depicts surface winds and significant wave height. Again, the seas are rather calm here at the moment. And let's switch to our regularly scheduled meteorology segment. These are the surface winds of the east. Shout out to our viewers from the east. These are your jet streams. These are the jet streams of the central world. Shout out to those viewers. These are your surface winds. Shout out to our viewers from the western world. These are our surface winds. And these are the jet streams of this side of the planet. And let's move on to take a look at clouds and fog. As we zoom in closer and closer to the lower 48, that's what's going on for clouds and fog. Here's a slightly closer zoom of the heartland. Check it out, folks. It's the hot air capital of the U.S. And next we're looking at a new snow thing. This is the new snow projection based on the Euro model. There's the GFS model showing a little bit less snow in New Mexico and Texas. The Euro model showing significant snow there in Texas. Also West Virginia, parts of Virginia. That is new snow for the next 3 days, and the heaviest will be in Washington. I think we said something about it yesterday. Washington there, going to see some extreme snow. Next, our weather.gov map. If your location is lit, head to weather.gov and click it. Those are too many counties for me to need to or want to go over on this video. Next, forecasts. Yeah, we got forecasts. You want forecasts? We got them. It's the GFS 72-hour pressure and precipitation forecast. Pacific Northwest is going to have 2 separate waves of moisture come through. We show 72-hour forecasts because they tend to be accurate. Also, Texas is going to get hit twice. The Gulf Coast there is going to see some extreme weather in about 2 days. So some big storms coming to both Texas and Louisiana there. There it is. There's the data, period. That's the GFS model. Next, our temperature anomaly forecast in degrees Celsius, the same model, GFS 72-hour. Things are pretty average over a large part of the U.S. here at the moment. Next, lightning. Quite a bit of lightning in South America. And here's a real-time lightning map, courtesy of lightningmaps.org. Next time you hear thunder, I highly recommend it. We've got some lightning in the Mediterranean there, also around Central America, it looks like. Some recent strikes in Honduras. We'll close this thing out with U.S. Doppler radar. Not the full 50 state, although there it is. We'll focus on the lower 48. There it is. That's U.S. Doppler radar. That's clouds and fog. And that is water vapor. This is a recap. Doppler, clouds and fog, water vapor. And here's me signing off. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.